Pluto is far away from the Sun, obviously. So, the Sun is on various occasions fainter than it is here in the world, so its frosty temperatures, diminishing to around -230 degrees Celsius during the nighttime. In a force wave, you could get as high as 170 degrees Celsius. It has a very problematic climate, excessively welcome curious personalities to an examination past the conspicuous spaces of our nearby planet group. Think about how conceivable it is that I let you know that Pluto, the distant and strange peewee planet, is finally making its incalculable move, perhaps colliding with, as a matter of fact, Neptune, the ice giant. Pluto's disobedient nature has been evident from the very start, a radical on the edges of our heavenly region. Its circle boldly experiencing another planet challenges the normal principles of planetary convey. I imply that is no kind of chap for a planet, right? From the confusing intricacies of Pluto's circle to the raised concerns voiced by astrophysical illuminators like Tyson and Kaku, a holding-up request hangs in the endless balance. Will these heavenly beasts partake in a compressed lesson? Could the combination of their ways spell unexpected implications for our cherished planet Earth? Today we set out on a gaudy excursion, loaded up with uncertainty. While the reactions to these divine inquiries could escape us right now, the potential for an impact of such vainglorious degree fills in as an unmistakable update that the universe is a stage for occasions both dazzling and perhaps a bit unnerving. Go along with us as we dive into the mysteries that circle how we may interpret Pluto and Neptune, looking at the possibilities of a radiant struggle that could reshape the limitless harmony of our planetary gathering. The stage is set, and the unfurling show tempts us to observe the jumbling dance of the planets, among other potential space calamities. The universe harbors numerous puzzlers, and among them is the bewildering conundrum referred to as the three-body issue. However, scientists expect other likely disturbances inside the heavenly theater. Although a planet colliding with another in space is highly unlikely, it isn't completely impossible. Gravitational interactions, as described by the three-body issue, are one of the forces that influence planetary orbits. A representation of a space system where gravitational forces produce a periodic pattern known as orbital resonances is TRAPPIST-1, which has 7 PL planets the size of Earth. As time passes, these patterns could threaten planet orbits, enhancing the likelihood of accidents. What is happening gets it done. Reject any accidents regardless of the reality that frameworks, for example TRAPPIST-1, are exceptionally thick and planets impact one another's courses, especially when they are close. Scientists consistently monitor these frameworks to sort out this. With this information, we can better handle how the planets travel through space. Another dark yet understood angle is maverick planets, which float thoughtlessly in space, as opposed to encircle around a star. Ejection of planets from star frameworks can occur because of gravitational pulls or other cosmic characteristics like another star's close methodology or dynamic shakiness in frameworks with more than one planet. Over time, these wandering planets can travel immense distances, possibly coming to regions a long way from where they began. It is conceivable that they will run into other star frameworks on their singular venture. The chance of a planet crash increases if one of these planets goes to another close-by planet bunch. In any case, a rogue planet striking another planet head-on is far-fetched, taking into account how tremendous and generally empty space is. The sparsity of planets in open space and the vastness of interstellar distances cooperate to hinder regular accidents. It is now exceptionally improbable that 2 rogue planets will influence. However, the frequency of rogue planets is far lower than that of stars and planets in stable circles. The star frameworks involved can become turbulent in the occasion of an inestimable combination. It is profoundly improbable that planets will influence head-on during these huge occasions due to the huge interstellar distances. The circles of stars and planets inside arising frameworks are changed emphatically by significant solid areas for the gravitational forces. A planet may turn into a maverick planet freed from any star when this sort of problem drives it out into the chilly, dull profundities of intergalactic space. Then again, planets could be catapulted from their circles, collide with one another, or even impact their host stars due to these gravitational unsettling influences. When gas and dust are packed under incredibly high pressure, gravitational breakdown can, all things considered, make new divine body structure, or maybe start stars to emerge. In our nearby planet group, The late weighty assault proposes that around for quite a while back there was a time of expanded influences including comets and space rocks. This flood in divine movement is accepted to have come about from gravitational unsettling influences caused by the outer planets. During this violent stage, gas monsters like Jupiter and Saturn were going through relocation, disturbing the circles of various more modest bodies in the Kuiper belt and space rock belt. Therefore, these more modest objects were tossed into unconventional ways, with many progressing into the inner solar system. This flood prompted a huge ascend in effect on the earthbound planets, including Earth. While these influences didn't include direct impacts between planets, they delineate how gravitational relationships can bring about huge changes in the directions of heavenly bodies. This assault is remembered to have played a critical job in molding the surfaces and land records of planets in our planetary group. Moreover, it could have added to the appropriation of water and organic materials to Earth, impacting the advancement of our planet over an extensive stretch. As stars go through changes in mass, flows then components of planets around them may end up further and potentially cross. This is especially noticeable in frameworks where stars are approaching the finish of their life cycle. As a star becomes older and consumes its atomic fuel, it frequently goes through huge mass changes, particularly during stages like the Red Goliath stage or when it discharges material in a planetary cloud. These variations in heavenly mass can significantly influence the gravitational equilibrium of the framework, causing the circles of adjoining planets to either move outward or become more conservative. This is bound to happen in multi-star frameworks where complex gravitational associations can effectively lead to unstable circles. In such frameworks, the gravitational forces from different stars can cooperate erratically, worsening orbital interruption and expanding the possibilities of circles meeting. This can result in circumstances where planets could get caught by another star, collide with other divine bodies, or even get shot into interstellar space. Pluto's interesting circle, at first perceived as a reasonable individual from the planetary family, went through a renaming in the long run, being designated as a smaller person planet because of its particular circle. The space community is as yet fascinated by it and finds it fascinating. Even with this adjustment, there's excuse to be stressing out regarding the closeness of Pluto's track to Neptune's. As per ongoing figures made by famous researchers like Neil deGrasse Tyson and Michio Kaku, these researchers are sounding the caution about a grave danger to Earth, the likelihood of an effect between the planets. Pluto is not normal for some other planet in our neighborhood makes planetary gathering, and this makes its circle around the Sun so unique. Pluto has not finished a full unrest since its discovery in 1930, and its circle runs and expanded 248 years. The way that it drifts off altogether from the bi- and large round circle of the enormous planets makes its course very unpredictable. Further adding to its standing, Pluto additionally has a more severe circle than different planets since its inclination to the ecliptic plane is 17 degrees. Adding flightiness to Pluto's orbital example is the mix of its curved shape and tendency. The place where Pluto's circle runs into Neptune's is an intriguing component. During around 20 years in each circle, Pluto adventures nearer to the Sun than Neptune, testing presumptions in view of their separate situations in the neighborhood planetary gathering. This leads to the question, why hasn't an effect between Pluto and Neptune happened? The clarification lies in the gravitational impacts applied by different planets. The appraisal of Pluto's circle began not long after its disclosure, presenting a confusing problem for cosmologists. In contrast to most of the planets, whose circles adjust relatively close to the ecliptic plane, Pluto's unique qualities incorporate a steep inclination and an elliptical shape. The mystery extended with the acknowledgement that Pluto's circle crosses that of Neptune. The three-body issue, Pluto's circle, remains stable in the midst of the intricacies, serving as a demonstration of the inherent intricacies of heavenly mechanics. Figuring out the motion and gravitational collaborations of three heavenly bodies like Pluto, Neptune, and the Sun is known as the three-body issue in space. Predicting their directions from their underlying positions and the impacts of gravity on each other is comparable. For Pluto, some of the terms that assist us to solve this galactic mystery are as libration, scope, libration, and the VZK wavering. According to astrophysicists, as libration is indispensable in light of the fact that it keeps planets in their circles. When Pluto crosses Neptune's circle, it is something worth talking about, like 90 degrees far off, which is a critical distance that forestalls influences, according to this definition applied to Pluto and Neptune's expansion. Libration insinuating the vertical movement of a heavenly body in its circle ensures that when Pluto approaches Neptune or other Goliath planets, it is situated fundamentally over their orbital plane, giving an extra layer of insurance against crashes, a fundamental component in understanding heavenly movement as the VZK wavering, named after three researchers, Van Lee and Kai. They investigated the gravitational associations between three space objects, for example, Pluto, Neptune, and the Sun. The VZK swaying sorts out why Pluto's circle around the Sun appears to be strange, however, remains smooth over the long run, in spite of the evident anomaly in space. Stowed away examples and rules keep everything in check. These factors together balance out Pluto's circle for stalling crashes with Neptune or deviations from its course. The three-body issue assists us with understanding how the gravitational pulls of these space objects impact their way. Taking into account this enhances our comprehension of Pluto, our neighborhood planetary gathering, and divine bodies. Numerical reenactments in the late 1980s revealed that, regardless of stable properties, Pluto's circle is without a doubt turbulent, with minor beginning deviations prompting tremendous contrasts over millennia. In any case, notwithstanding this inborn tumult, Pluto's circle illustrates surprising stability over broad periods, actually mitigating predicted disturbance. Late computer experiences have expanded how we might interpret the complex elements, including the impact of enormous planets like Neptune, Jupiter, and Saturn, on Pluto's way around the Sun. Neptune's particular gravitational impact, finishing three circles for each two of Pluto, essentially adds to the general stability of Pluto's orbital way. Jupiter's gravity is also critical but less so than Saturn's. Taken together, these observations show that Pluto is in secure and consistent motion across space. More than billions of years, it is pivotal to continually notice and explore. In space, these occasions, space investigation, much of the time, reveals the unusual way of behaving of divine bodies. Pluto's circle is an exemplary illustration of this unusual conduct. It represents how minor changes in the Bantam planet's area or speed can significantly influence its orbital way. Scientists' comprehension of Pluto's movement in space is to a great extent due to programmatic experiences, which imitate the gravitational collaborations between Pluto and other planetary bodies like Neptune. These ulations use complex numerical models, allowing space astronomers to recognize how small changes can significantly affect Pluto's way. The instance of Pluto gives a distinctive outline of the concept of orbital tumult, exhibiting how the direction of a divine body is deeply subject to its beginning stage for a really long time.